Hi there, welcome to the lesson, The Power of CyberChef. So what's this lesson all about? It sounds a little bit mysterious. Well, I'd like to provide, before we really got into the meat of the course, just an end-to-end walkthrough from the beginning to the end of how you might use CyberChef in a practical case study. And that practical case study is going to be the analysis of a suspicious Microsoft Word document. This is a really common scenario that anyone in digital forensics, incident response, working in a SOC or an IR team will come across, that a user or some telemetry has highlighted a Word document. It could be an Excel document, it could be a PowerPoint document, but some sort of suspicious Office document that needs further analysis. And it's up to you to do this analysis. So what we'll first be doing is we'll be putting it in a program called Office Mal Scanner, and we'll be doing this in a virtual machine that's customized for malware analysis. Now, don't worry about the details of this. We'll be running through all this stuff in the course: how to set up a malware analysis environment, how to look at malware safely, how to use all these programs, and then how to perform this analysis in CyberChef. So I don't expect you to follow along in this. I just expect you to take it in and understand that CyberChef can be used within this whole process to provide answers to questions that you as a security analyst may want to answer. So running it through Office Mal Scanner, we'll get out some Visual Basic macros. We'll then load these into Notepad++. Looking at them in Notepad++, we'll conduct an initial triage, and then we'll be putting them into CyberChef to deobfuscate the Visual Basic macros to try and get some indicators that then we can pivot off and look further into our other telemetry, whether it be DNS logs, whether it be proxy logs, or artifacts that we might have got from the user if we do believe that the user has clicked on the document and maybe executed these macros. So, without further ado, let's jump in and take a look. So here we are in the Flare virtual machine. Now the Flare virtual machine is a VM that's specifically tailored for malware analysis. It's put together by Mandiant, and they have configured it with a whole bunch of really useful tools that can be used for all sorts of malware analysis, for looking at binary files, for looking at other sorts of obfuscated code, and also for looking at Office documents. It even includes a copy of CyberChef, which just gives you an indication of how important they think CyberChef is as a tool. So what we're going to be doing, we've got our file suspicious.doc that we've copied over to our desktop here. We're going to be using a program called Office Mal Scanner, and we're going to be loading up suspicious.doc with the info flag. If we look at that, Office Mal Scanner is just a great quick program that looks through Office documents and other sorts of compound files that have that structure, and it searches for Visual Basic code. It's found 3 scripts. Now, as you can see here, the names of these scripts are completely nonsensical, which is a really good indicator that you're probably not dealing with a legitimate document. They don't have any meaning at all. The macro code has been decompressed and it's been saved out to a folder on the desktop. So we can load it up, and you can see we've got our 3 macros here. We've got our first one, which is 5 kilobytes. Our second one, this WTS script here, is 42 kilobytes. And our third one, ZBV, is 3 kilobytes. So we can load these up, and then we can have a look at them in Notepad++. So we'll take our 3 documents and highlight them. Right click in Flare, and we can use the Edit with Notepad++ option to load them up in Notepad++. Now, Notepad++ is a really great just all-purpose text editor. It really is just handy just to have a look around your documents first before you try and do any sort of deobfuscation, just to take a look at really what's going on. So we'll take a look at our first script, this SOW script. And we can see we have a lot of variables here that are declared. We've got a lot of these mid functions. We've got these left functions here. And really, we just have to sort of start either doing some research into what these do. So we can just jump to Microsoft Docs. We can see that mid, it says return string contain a specific number of characters from that string. We have the string, the start, and the length. So we'll go have a look. So we've got the string, which is this concatenation here. the start, which is 97, which probably doesn't exist in that length, and then 437, which is way too long. So going back, we can have a look and we can say, if start is greater than the number of characters in the string, mid returns a 0-length string. So it's not going to return anything. So this kind of lets me think initially straight up that this is probably just junk code. It's not returning anything. So if it's not returning anything, it's not doing anything. And that can be confirmed, but if we have a look, see if this is referenced anywhere else, we can see that it's only referenced in these lines 10 and 11 of this script, which means that really that variable is not doing anything. And that's something else that you can see if you did more research on these left functions and then these mid-B, you find that they don't really return anything or they return junk. And that's really a common tactic that malware authors use to fill up all these sorts of space, just to try and confuse anyone who's looking at the script. If we jump over to the second script, we can see that, again, there's a whole bunch of these mid functions, mid-B, left. But what does stand out that's different is we've got this sort of obfuscation here with these carets, quotes, underscores, and we can see that again here. So what we might do is look and see where this is referenced, this OINRCZ function, variable. And we can see it's referenced in line 14, but also line 68. And if we jump down, we see this CyberChef variable has that one concatenated with 1, 2, 3, 4, 5, 6, 7, 8 others. And you can see these 8 others here match these other sort of obfuscations. So what we've got is concatenation of all this put together, which is interesting. And if we go down, we can see more of these. Similar sort of obfuscation hidden between this junk code. We can search for that. And again, we can see it's in line 89 where we are, and line 118, which again is more concatenation of these strings. And you can see that last one there. So really, we can keep going down. In the end, we see that these variables, again, are here. And we can look and see where this sort of master variable of these concatenations is referenced. And we can see it's referenced in the script that we're in, this WTS script, but it's also referenced in our first script, the SOW script up here. So we'll jump to that. And we'll see we've got this one here, which references CyberChef, and there are other ones. And here we've got this key string VB key C, key string VB key M, and then our concatenated obfuscated code, which is very interesting. So again, we go back to the Microsoft documents to look up what key string is. And we see returns a key combination for the specific keys, for example, Control-Shift-A. So what keys is it returning? VB key C and VB key M. So we can look up the key codes if we're not sure. We can see VBC key C is the C key, and non-surprisingly, VB key M is the M key. So essentially, this is returning C, this is returning M, and then the start of our CyberChef value. And if we go up to our CyberChef, the very top, it's going to be the first one here, which is this is the first bit of obfuscation in that CyberChef variable, and we can see a D. So really what we've got is C, M, and then D, and then the start of this obfuscation, so command. So immediately command indicates that something's going to be executed, and this is now turned really interesting. So what we want to do is really we want to pull out all this obfuscated code, get rid of all this junk code, and then see what data we've got, and then if we can deobfuscate it. And the perfect tool for that is going to be CyberChef. So let's load it up into CyberChef and see how we can deobfuscate it now. So loading up data into CyberChef couldn't be easier. We'll simply select the entire script, copy the text, and load up CyberChef and paste that into our input window here. Now I'll just maximize Chrome just to give us a little bit more room to play with. So once again, this is a demonstration of the overall functions of CyberChef and how you might use it in an end-to-end example to deobfuscate malware. I don't expect you to follow along at this point in this deobfuscation. All the functions and techniques and operations that we learn when we build this recipe will be running throughout the course. And I promise you that by the end of the course, you'll have great confidence to be able to take a script like this and deobfuscate the malware similar to what I'm doing now in CyberChef. So the first thing we want to do is we want to get rid of all this junk code and only return what is our interesting obfuscated code. And probably the best thing to do, the best way to do that is with regular expressions. If we look at the junk code compared to the obfuscated code, we notice the obfuscated code has these quote marks at the start and end of the interesting data. Now there's other data here that has those quote marks that is not interesting, but the bulk of the garbage code doesn't have that. So by using a regular expression, we might be able to slice out that data of interest and not have all this junk in the middle. So by searching for regex here and double clicking, we can then start building a regular expression. And the regular expression we're going to build, which we'll talk through later in the course, is look ahead and look behinds. So we'll build that in the window pane. And essentially what this is saying is take everything that starts with a quote mark and everything that ends with a quote mark and give me everything in between but not those quote marks. And you can see how this works in this first example here. We've highlighted the WTS up into the PBI but not the quote marks. If we scroll down, we see more highlighted data, which is great because this is our obfuscated data that we actually want to slice out. You notice our junk code isn't highlighted because it doesn't match the rules of the regular expression. We've got more code that's of interest. So when we're confident that the bulk of our regular expression covers the code, we do have this one false positive at the top, but that's okay. We can deal with that later with another operation. Once we're confident, we can change the output format to highlight matches to list matches. And we have our obfuscated code here. We can then look at filtering out this data by using the filter operation. And that uses regular expressions as well. So we can use just itself and we can invert that to say anything that's not this, we want it returned. We can then go back to another find and replace. And we can use just finding all the carriage returns and replacing them with nothing. And here, if we move the output pane up, we can start to see our block of obfuscated text. And this is what we wanted to pull out from all the junk code. So this is our block of obfuscated text that we'll then start working on to see if we can make sense of it. So where to from here? What I'd probably do is tackle something like this, which looks like it appears a couple of times. So first we'll just do this calculation here, which is 6, 8, 13, 34. So it's the character code 34 converted to a string. Now we can pull up another CyberChef window. And type in 34. We can go from char code. And we want base 10. So we can see that 34 equates to a quote mark. So this phrase here simply equates to a quote mark. So we can use our find and replace tool again to keep building up our recipe. And we can replace that with a simple quote mark. Just make the screen a little bit bigger for us. And by using the toggle here, we can see where that's been actually enacted. We can see it at the top there, and we can see at the bottom, and we turn that back on, and we can see that now that's been changed into a quote. That's been changed into a quote there. So we've got rid of that big long calculation. So where do we go from now? Well, really, it's a case of if you hadn't seen this type of obfuscation before, you turn to Google because there's potential that someone else has and they've written about it. So what would you Google for? I'd Google for Windows malware, Windows command line malware, Windows command line malware with carrots. They seem to be quite frequent. And if you did variations of that, you'd come across the term DOSfuscation, which is a type of Windows command line obfuscation that's heavily used by different types of malware authors. So reading about that, you can learn the rules of how DOSfuscation works, and then you can apply those rules in CyberChef to deobfuscate the malware. So again, what we're going to be doing is building up a regular expression saying all the characters that we don't want to remove this extraneous obfuscated data and leave us with the code. To start with, we'll remove some spaces. We'll then remove the carrots. We'll then remove the plus signs. And all we're doing here is we're building up a regular expression as we go, and we can see the output in our output pane and determine maybe we removed the wrong character, or maybe we've done enough and we can stop. But this is simply any white space with a pipe as or, any caret, or any plus sign. We can keep going with underscores. We can keep going with dashes. We can keep going and we can see what happens if we take out the backslashes and then the forward slashes, and we get to a point where we've only got letters and numbers and some other characters left. We start to see sort of things that our eyes settle on as potentially interesting. So if we look through it, we can see that set, and then we can see this HCTAC, which is actually catch backwards. We keep going, we can see KAERB, which is break backwards. We keep going along, we can see things like download file here, that's backwards, and other phrases. So we want to reverse this text. Now that's reversed, everything becomes a lot clearer. We can see PowerShell, new object net web client. We can see this variable, PowerShell variable BZI equals, and we can see this HTTP, HTTP, HTTP. What might have happened in our eagerness to get rid of some of the obfuscated slashes, it's also taken away some forward slashes that were probably used in these URLs here, which is okay. We can replace those later. We can see this split at the @ symbol, another variable, JQP177, and we can see that referenced again, jqp.exe. So we've got a potential file name here, 177.exe, which is placed in the environment path, the public environment path. And we can see the end of the script here, and there's our catch break that we saw at the start. So really what we want to do is look at these domains, these URLs, and try and pull out these domains. So we might just do another find replace and restore some of those slashes that we took out a little bit too eagerly. So we're just finding HTTP and replacing it with this slash. And this makes a little bit more sense. We've got these domains, or these URLs are going to be split. We can see .com, and then here, probably it was .com/ and then this resource, and then .org/ this resource. But it's okay, we've got these domains here, so we might be able to pull them out using this extract URLs function. And then, before we copy them over anywhere else, we might defang them, just in case we don't want to accidentally click on them and infect ourselves. So we've got here our domains. We can copy them out, put to the clipboard. We can open up a new Notepad++ window. We can clean them up. If we wanted to, we could put those slashes back in if we wanted the resources. but let's just leave it at the domains. And now we've got 5 URLs which we could go look across our network. So where would we look? We might look in first DNS logs to see if any of these domains had actually been resolved in our DNS. If we had proxy logs, we could see if the proxy had reached out to any of these domains to see if it did indeed grab this file. Let's go have a quick look. See if it grabbed this file 177.exe. We could look at individual endpoints we thought were infected at their browser logs to see whether the browser history had any reference to any of these domains. We could start proactively blocking these logs if we had that sort of capability in our network. We could block these domains so that if anyone else received this suspicious document, it would block any sort of communication with these domains and prevent that executable from being downloaded. So very quickly, using CyberChef, we've taken what is quite a foul looking obfuscated text, and we've translated it into 5 domains and the name of one executable, which we could now hunt across various endpoints and our network. And that's really what we want to do. We haven't understood every line of the script. In fact, there was one macro that we haven't even looked at yet. But it's fair to say that by using the tools at our disposal, we've very quickly gone out and got the indicators that we want, which is files that are potentially going to be downloaded and domains that are going to be contacted. And we've done that very quickly by building up a recipe in CyberChef using things like regular expressions, reverse, filters, find and replace to extract out the data that we want to come up with the end result. And that really is the true power of CyberChef. And I hope that that gives you a great demonstration of what we're going to be learning through in the course and discovering more about its capabilities every step of the way.